Namaste. Today we are going to start mathematical induction. Okay. So mathematical induction is a method to prove the given expression as informal proof and formal proof. Okay. So in this method we have to follow two steps. This is called basis step and inductive step. For basis step we consider for a simple instant it is true, and in inductive state we assume it is true for n, and we have to prove it for n plus 1. So let us consider an example to show 2 plus 2 square plus 2 power 3 plus 2 power 4 plus ... plus 2 power n is equals to 2 power n minus 1 minus 2, where n is must be greater than 1. So given, let us represent by a predicate. Pn equals to 2 plus 2 square plus 2 cube plus 2 power 4 plus ... plus 2n is equals to 2n plus 1 minus 2, n greater than 1. Yes. So basis step, let us consider n equals to 1. So p1 is equals to 2n plus 1 minus 2 is equals to 1 plus 1 minus 2, it is 2. That means it is true. So we move it to inductive step. Now in inductive step we assume it true for k, and we have to prove it for k plus 1. So pk is converted in terms of n, we write k. Okay. Now pk for pk plus 1 step. So pk plus 1 is 2 plus 2 square plus 2 cube plus ... plus 2k plus 2k plus 1, and k is converted into k plus 1. So up to this term we have the value 2k plus 1 minus 2. So that is 2k plus 1 minus 2. This one, yes. And 2k plus 1 plus 2k plus 1 is 2 into 2k plus 1 minus 2, and it is 2k plus minus 2. And similarly we open the braces here, we get 2k plus 2 minus 2. So RHS and LHS both are equal. That means which is true. Yes. So by mathematical induction, the given statement is true for n and n plus 1. Okay. So let us move to the next example. Okay. So prove that 8 power n minus 3 power n is divisible by 5. Okay, where n is greater than 1. So our Pn is 8 power n minus 3 power n is divisible by 5, where n is greater than or equals to 1. It's basis step. Okay, let us consider n equals to 1. So P1 is equals to 8 power 1 minus 3 power 1 is 8 minus 3 is 5. So which is true? Yes, as 5 is exactly divisible by 5. So let us move to the inductive step. Okay, so let the statement is true for t. Statement is true for k for arbitrary k. That means pk is equals to 8 power k minus 3 power k is divisible by 5. So we have to prove it for k equals to k plus 1. That means pk plus 1, it becomes 8 power k plus 1 minus 3 power k plus 1. Okay, it is equals to 8 power, so we remove 8 into 8k, that means plus 1 means we remove the power, 3 into 3 power k plus 1. Yes. Okay, so 8 is, we know that 5 plus 3 minus 3 into 3k plus 1. So by multiplying we get 5 into 8 power k plus 3 into 8 power k minus, so this is k only, not k plus 1. Okay, and it is okay, and it is 3 into 3 power k. So 5 into 8 power k plus we get common part is 3. Okay, so 8 power k minus 3 power k, and we know that 8 power k 3 power minus 3 power k is exactly divisible by 5. Yes, from this statement, so it is exactly divisible by 5, and again from this it is exactly divisible by 5 since it is multiplied by 5. So here 5 into 8 power k and 3 into 8 power k minus 3 power k both are exactly divisible by 5. So it is true. Yes, it is true. That means it is true for n and n plus 1 term. So by mathematical induction we can verify or prove that 8 power n minus 3 power n is exactly divisible by 5. In this way we have used the mathematical induction to verify or to prove the given statement. Okay, and in next video we will be continuing with recurrence relation. Thank you and bye bye.